Hello again, just some more difficult turtle surface area. So I'll just say the harder ones of the turtle surface area. In other words, the year 10 stuff. And again, they're just formulas. There's nothing really to be scared of. It's just knowing how to use the formulas, plugging in the numbers and smashing them up. So total surface area, what we're going to look at is our sphere. Now, please, once, no, I won't say it. I'm embarrassed. Now I'll say it. I've seen a sphere spelt like this before. Sphere. Please do not do this. Sphere like that. Here we go. I'll try and draw a sphere. It's the hardest object to draw. I'm sure Cassandra will be able to do this way better than I can, but there's probably shading and stuff like that you can do, but to sort of show that it's three-dimensional, very, very difficult. Should I have a try at shading? No, I'll ruin it. So if you've got a sphere, which is just a tennis ball or basketball or something like that, of radius r, okay, so it's got radius r, then your total surface area of your sphere will be equal to, surprisingly enough, you think it might be something complicated, but it's not, 4 pi r squared. In other words, if you take a circle of radius r, then you can sort of like paste 4 of those circles around a sphere. Pretty cool. I'll prove this in class. So that's very good. So there's your sphere. And the other one that we want to know is a cone. Cone, if you've got, I'll try and draw one. Might be very good. I screwed it up. I'll start with the pointy bits. That's easier. And you've got that and that. So if you've got a cone like that, and you know its radius r, and also its slant height. That's a new thing. Slant height, which is this diagonal here, slant height s. Then your formula for a total surface area of a cone is equal to pi times r plus s. That's as easy as that. And if you expand that out, you get pi r squared. That's the base. The area of the coney bit at the top is pi r s. So you can sort of break it up into its pieces if you want to. Pi r squared plus pi r s. Okay. Base of the cone, cone of the cone is sort of the toppy bit. Okay. These are two formulas. And this one. And again, if you know the formulas, just do the examples. Here we go. Shouldn't be too bad. Shouldn't be, but it is. Good example. Let's do one. Gee. Now I can't even bother doing those easy ones. Let's do this. Let's do half a sphere. That's not bad. What a good drawing that is. I hear you all at home applauding that magnificent drawing. So let's just say that's 7 meters. 7 meter radius, and let's find the total surface area of this. Okay, now don't go smashing into this. Oh yeah, it's just half of the area. Don't go like this. Is equal to half of 4 pi r squared. Don't say that. Why not? You say because 4 pi r squared is the total surface area of a sphere. Yep, no, and it's half of that. Yes, this is true. But this is that would only tell you the total surface area of that outside sort of bit. What it doesn't take into account is this stuff on the inside there. So just be really careful. Yep, half of the sphere, but you also need to add in, you've got this extra bit down in here, which it will be a circle because you've cut the sphere into half. So it's like half of an apple or something like that, plus pi r squared. That's the pi r squared, that's the area of a circle there. Okay, and half of 4 is just 2, so that's 2 pi r squared plus pi r squared. So in actual fact, that's 3 pi r squared. You didn't necessarily have to do this, but this just makes the calculations more simple. Equals 3 times pi times the radius is 7 squared, which is equal to 7 squared is 49. 49 times 3. 49 is 27. 12 147. I should have been able to do that in my head. Idiot. It's just 50 times 3 minus 3. Ugh. 147 pi. There's your answer. 147 pi, and we're in meters squared. Done. Total surface area of an apple core. Half of an apple core. Half of an apple. Okay, let's do another example. What was the other shape I had to do? Oh yeah, a cone. Why start with that really? I should start with this. Cone. Doop, 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 doop. That's a pretty good one. Ooh, let's say this. 4. Let's say this is 3, and that'll do. Okay, find the total surface area of this. Good. So, firstly, write down your formula. Total surface area of a cone is equal to what? Remember the formula? It was pi r plus s. Good. Pi r plus s. Now, what is the radius? Our radius is equal to 3. And what's our s? S is this length here. We don't know it. So this is our s. How could we find out s? We're not told what s is equal to. If you're able to use Pythagoras, which we could in this case, we can find out what s is. So remember, Pythagoras will say that s squared is equal to 4 squared plus 3 squared, which is equal to, so s squared, therefore s squared is equal to 16 plus 9, which is 25. Therefore, s is equal to square root of both sides, the square root of 25, which is equal to 5. So s, that slant height there, is equal to 5 units. Fantastic. Now we can find our total surface area. Total surface area is equal to pi times the radius, brackets r, 3 plus 5 there. Okay, so that is 3 plus 5 is 8. 8 times 3, 24 pi units squared. There's your total surface area for this cone. Nice. Beauty. Thanks for listening. I'll see you in the next video.